Alright, this is your assignment from yesterday, so make sure you got this out. This is the same assignment for honors and general. General will be a little less emphasized than a couple things I'll point out, but either way, can't hurt. So what factors could a person change in order to convert a liquid to a solid? We talked about this previous to this. This is involving a triple phase diagram, and you should be aware that obviously temperature and pressure. If one person wants to make a liquid to a solid, utilize the answer from number one to describe how you might do this. Well, you can increase the temperature, or you can decrease. Well, if you want to make a liquid into a solid, technically you would do it the other way around. I can reduce my temperature and increase my pressure. Statement: everything dissolves in water. Why do things dissolve in? Well, in this case, things are positives and negatives attract. So in this case, if something dissolves in water, it's because it's attracted to water. What force is causing this dissolving water? We'd call it Coulombic attraction. Another name might be electrostatic attraction, or should be positives and negatives attract. Here, it's asking for draw a picture of beakers below 5 particles. So carbon dioxide is a molecular compound. So when it dissolves, it just stays together, and it just floats as a whole molecule. Lithium nitrate, however, is ionic. It splits the cation anion right here. So I'm going to have 5 cations. And 5 anions. Magnesium chloride is going to split into 1 magnesium. I'm making a little key here, because I'm going to use these positives and negatives to represent the cations and anions. So there's going to be 5, there'll be 5 cations. There's 1 magnesium every time this thing breaks apart, and there's 2 chlorides. So 1, 2, 3, 4, 5, and there's going to be 10 of my negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Gets a little crowded, trying to picture out. What is the difference between each substance relative to bond type? So what's the difference? Well, the difference is ionic compounds. Okay, they dissociate. The covalents just stay together. How many chloride ions are floating around in the solution? Well, we had 10 of them. Because every time you have one ionic component, it doubles into 2. So we had 5, so that gives us 10. How many chloride ions would be floating around if I had 100? Well, 100 of these guys, again, 100 times 2 would equal 200 chloride ions. If I have 50 grams of magnesium chloride dissolved in 50 milliliters of water, okay, let's answer the questions above. I've seen some kids yesterday just giving up at this point, but it's really a lot of the same stuff that we've been doing. I got 50 grams. Outline, get rid of grams, and go to moles. 1 mole for magnesium chloride. You'll need to add that up off the periodic table. Magnesium looks like it's what, 24 plus the chlorides. I'm going to round it up to right around 95 grams is equal to 1 mole. So we have a little more than a half. 50 divided by 5 means we have 0.52 moles of the magnesium chloride. Alright, that's letter A. And then we have letter B is how many moles of the chloride ions are present. Alright, so I'll put B right here. Well, every time you have one of these guys, you get 2 chlorides. So it's going to be 0.52 times 2 equals, and that's going to be 1.04 moles of chloride ions. And the next one says, what is the concentration of the magnesium chloride? So that means I want to, for C, I'll put it right here. We have 0.52 moles of this magnesium chloride divided by 0.05 liters. It's going to be 10.5 moles per liter. And next one says D, says what is the concentration of the chloride ions? Okay, well that's going to be just taking the moles of the chloride, which is 1.04 divided by 0.05 liters. Should we double it? 1.04 divided by 0.05 equals 20.8. Alright. And finally it says if another person adds 50 milliliters of pure water to beaker in question 7, by what factor will the volume increase? Well, we're going to times 2. What is new concentration? Now I'm going to do the concentration of just the magnesium chloride. That's generally what we look at. So if it goes from 10.5, it's going to drop to 5.25. It'll cut in half. You can use your molarity formula to calculate this as well, but in a sense it's just a reciprocal proportion, and you should be able to handle that. Your quiz is tomorrow. Make a note card. Note cards are up front. Thank you.